Hi everyone. Today we will study about the 2D excavation with and without retaining wall to consider about the displacement of the soil when we do excavate with and without the retaining wall. So first of all, I would because it is the first lesson, so that's why I would like to introduce some of the function and the tutorials manual used in the my.GTX NX. Firstly, you open the GTX NX, and you can open the new file. With this new file, you can see GTX NX, including the geometry. In this geometry, so you can draw the data with 2D and 3D functions. You can move, translate the transformers, remove or extract. So after that, in method GTX NX, they will obtain the mesh sets based on the geometry. So from that, but first you need to import or create the material and then properties for your model. You can control the size control to have the better control of the mesh size in the area you want to consider the stress or the displacement. You can generate the 2D and 3D, even 1D mesh in here by this function, and then also have the create, delete meshes or extract meshes something. And then after that, you go to the static slope analysis. In here, you can create the state sets with the construction stage, and you can use the state wizards in some cases of the analysis. And then in my GTX NX, it have various boundary conditions you can define in here. Along with that, you can have the various load condition, and after that you can have the seepage consolidation analysis. In here you also have the varieties of the boundaries, but for the seepage condition, and dynamics analysis, thermal analysis, for your model. And after that, you go to the analysis tab. So in here, you can go directly to the model tree. You can have the model analysis and results. So this is analysis. You can control in here by the analysis case, state, or in the analysis tree is very important because you can turn on, turn off the geometry directly in here. And then after that, you can, after running, you will have the results like after processing it. And then you have two. You have a vertical tiled and horizontal tiled. With this function, you can compare the results, have a better understanding of your results. Okay, now let's get started. First, I will turn on the new page. So you link to the new page in this function, and then you choose 2D. In this study, we will mainly study about the 2D in this analysis, and then you click OK for the 2D. And now to import the data, I would like to introduce the location for you to study. So you will go to the MyDats, go follow this link. You go to the C, and then profiles, program files, MyDats, and you can see my.GTX NX. In here, they add two folders for you to reference. This is the manual. In this manual, you can have the benchmarks and analysis reference. Beside that, you can have the tutorials, actually. So in tutorials, you can have 10 tutorials in here to understand the functions in my.GTX NX. Now we will study about the first one, we will study about the excavation with retaining system. Okay, so now I will import the drawing. So you can see like in here, they have drawing, uh, the drawing like the AutoCAD drawing to import, and we start to import now. So we will go to import, and here you can see DWG wireframe. So we go to that and select that file. So in here I create a new folder in the C disk to have a better performance for the result. And then I open it, so you can see import limit is from the 2010 for the AutoCAD. So you choose this and open, and now you can see the files is imported into the X and Y surface, and now you just click apply. Okay. So now you have the different line, but you see this line is a crossing, but they don't have different line in the crossing location. So we need to handle it in Midas GTX NX. Firstly, in drawing, maybe you have the WK line, maybe below this one have two line. We don't know, so may cause some the error in the analysis, in the results when we choose. Maybe we choose one, but in my GTX maybe two, so it's causing some errors. So now you can check first. You can check the duplicates. Use all your line and your drawing, and then apply. So you can see no line is highlighted. It means no duplicated line. And go to the intersect function. In this intersect function, you see this is crossing together. But now we choose this function, and then we choose apply, and then do this function, and the crossing is different now. So each of the intersection is have a different line, as you can see. And okay, that is the first step for the handling the drawing data. The next step, you will choose the make face to make face for your model. Okay. And you select the cover area, and then click apply. So you have the full area in here. This is the face you create for the cover, and but you have some line and regions, so to separate the regions in here. So you can choose the imprint function, choose the face you have been created, and then select the two objects, and then you can select the direction of shortest path line. So it will cut the face that you created into the line existing inside. So you have applied. Okay, now you have the different areas. When you can see clearly when you go to the mesh function. Okay, and with the mesh function, we need to add the properties first. So to save time, now we will import the function we used from the manual. So you can take the file from our study, just 5 properties. So we have 5. You can rename the new ID. Start with 1 here, and then you can close. And now you have 4 material because you import properties. So after the step of material, so now you have 5, including the materials and properties of it. Now the next step is you create the size control, because in this area you want to have the higher accuracy in the results of the displacement, the stress of the soil. So that's why you will go to the size control, and after it is appear the top here, you can choose the pilot, and we want this length also. So we want this length, and we want this area also. all of this line we want to control with the max size 0.5. So I have 0.5 method for each point along each length we choose, and the distance is 0.5. As you can see here, and the distance is 0.5 now. And you can go to the mesh control by create generate mesh. So now you have different area as you created last time by the imprint. Now the mesh you control with two methods from the menu. So you have the soil one, and you create the name for your message is soil one, and then you choose the soil layer, and this is soil one of yours, and you apply. So now they will generate is as the soil with two method, as you can see. And now you can recheck the length of the message, because now you have 0.5 here, and you can see here 0.5. So you can see now we have the soil one layer, and when you choose the soil one, this is full because you create the soil one. But in when creating a mesh, we should because now we want to have the excavation in here, so we don't want, actually we want to separate this area, and then later we can group this part and do for the excavation. So that is the wrong way, because we not separate it for the next state. So if you do like this one, you cannot do for a full like this. So it's have a function to separate when you make the 2D. So now we will back to the 2D, but it also have a function is undo in Midas. It's very advanced function for you to get back, go back. Okay, now you back at the window, right? Without that, and now you turn on the geometry back, and then you can choose the 2D again. Now you control the method add 2, and then you select the soil one, and create the soil name one, and here you can see this have an extend function advanced option, and here register each mesh independently. So you need to click in here, and you can choose OK, and from this function it will separate area from the faces. You have how many faces it will create and how many mesh sets. Okay, and now you choose. See here already 2, 3, 4, 5, 6, 7. So it will create 7 mesh sets for you in the soil one. Okay, and then you apply it, and you can see here is a little bit different. Like last time just soil one, but now soil one and 416. It means 7 mesh sets in here. So you can see by going to the basics and the face, but you need to open again for the geometry. So we repeat for the soil 2. So the mesh size 2, soil 2, you create the name for soil 2, and then select the register each mesh independently, and then choose the face that represents for soil 2. So you have the soil 2 here, and then you click apply it. So see in soil 2 and meshes, and then do for soil 3, but you need to turn off the geometry back, and then this is soil 3 layered, this is soil 3, and then apply it. So soil 4 is select soil 4, change the name soil 4, and then turn on the geometry, and then soil 4 and apply it. So now we have totally for soil is set up, but the properties you can see in here. Yeah, so different colors. So you can turn on in here, choose the cube of mesh cube, and then you select the property color. So now see it's represented for 4 color here. Okay, so now the next step is we create the um, we include on these different mesh sets on the different mesh set here as the excavation layer 1. So to do that, we need to go to the mesh and then in the model tree, and then select this one, and you have here, and then you include element nodes. Okay, and then you include it. This means you choose the basics and have mesh set here, and this one you click 1 2 3, and you will include all of this into one. So you include and then click apply, and don't delete the previous one. So you have the first one, and you know now is this is the excavation one. So you change you click F2 on the keyboard, and then use excavate one, right? Or you can fastly X1. So it means excavation one. Okay, layer 1, and you enter. So this means now is this one is excavation 1. If you turn off, you don't have. If you turn on, you have. Okay, and now do the same like that. So you choose the message you want to include, and then exclude, and then choose, and then select the basics, and you have message here, and you select. This is the soil excavation 2. So layer 2. So we apply it, and after apply, you turn off to change the name. So this one F2, and then excavation 2 layer for the layer 2, and then include, and select basics, and then select layer 3, and then apply it, and then choose this one, and then rename. So rename here, and then excavation 3. Okay. So after creating the excavation for three layered of excavation, now you can go to the next step, is the static step. Okay, so in here you create the loading, but in this study, firstly we just want to do the excavation, and now you do the constraint, because this is just can settle, but the two sides, left side and right side, just settle without movement left and right. So that's why and in the bottom you constrain it moving x and y direction. So you go to constraint, and it have an auto function if you follow the gravity. So this is and the setup, this is a xy surface, so it will automatically, this is a boundary condition. You can change the boundary condition set name here. I try B and C for represents for boundary condition, and I click apply for it. So you can see here is log the x direction, and just have the setup for the soil, and then this is a fix at the end. So after creating the boundary condition, now we go to the stage set to select the type of simulation. So we want to simulate the stress. We have different stress consolidation, seepage, or couple analysis, but we in the study we mainly focus on the stress, and then we add it. So this is the construction stage 1. You can rename here for the excavation without retaining wall. So you can modify, and so this one will change to the modified one, and you go to the defines construction state, and then here you can create create the construction state for it. So firstly, you need to have the initial to represent the field stress of the soil. You have the initial, and then you choose all the soil inside, and so to easier, it have a function to see what you applied in your model. So you just you can see here, I will show for you by the activate function. So now you get back here. So now firstly you don't have anything, and then you activate your model and select all the mesh then put into the activate the data. So you can see now you input all the 4 layers of the soil, and then you create the boundary conditions to analyze, and then you create the self weight. Self weight is automatic at the first by the gravity. So you can see gravity. Now they ask for the particular name, so you can write the name this excavation. So excavation, excavation uh, without without retaining wall, right? Without retaining wall. Okay, and then you have the name in here. And now you, after you creating all the initial condition, you save it. Okay, you save it, and you have the initial state 1, and you want to consider the new stage. You click new and change the name for the construction state. So we do the excavation layer 1. So you take the mesh test of excavation 1 to the deactivated data, and then you save. So you have the excavation 1. So you do like this for excavation 2. So you must have 1, and then you click save, and then you click new, and then you define the new name for excavation 2, and then you save. Now you see this is the soil for 2 layers is excavated, and then you click new for the excavation 3, and you click excavate layer 3, and we save and close. So we have just finished on this, but I forgot one thing that is also important. So like you can see here, there's an initial state. Firstly, you create a gravity so the soil, but you don't want the soil settlement in this state, right? The first state is you just create the stress of the field, and then without the without the displacement at this stage, we just want the displacement after we have the excavate. So we do this, we clear the displacement in here and save. So now we can close. So close again, and after we have the stage set, it will in here. So you can see without excavation, what you have excavation 1, 2, and 3. So now you create the analysis case, you add it. Actually, it's similar in the function in here. So analysis case is same as the general in here. So but now too easier to do, so you can go to the analysis tree, and then in the title you can say without like excavate without retaining wall. Okay, and then you can choose the construction state. Last time we defined the state set is for the construction state, and you can see here after you choose this, state sets will appear in with the name of the construction state that we set. And then because we do the gravity, so this analysis we don't consider it by the case or condition, and then we apply it. Okay, now you can see here is the Harvard analysis case in here. Now you just click solve, and the model will start solve the problems, and you can see this is the analysis quite fast for the 2D excavation, and you can see it's doing the convergence and then find out the results. So to just have some function in here for you to do is you can improve by the number of processors in here to faster your process of simulation, enable GPU acceleration also, and some case standard statistics is faster, no need to have the accuracy of the element formulation. Okay, so after doing this calculation, you can see from the computer is have the CPU time and have the time work log times of the calculation, and you can see number of threads here is the processors you set up in this analysis option. Okay, so now you can go to the results, treat to see it. So after excavation treat, how about the soil displacement? So you can see the increment here, and then you can see the soil because it's the xy direction. So you can see the ty translation. It means the displacement follow the y direction. So you can see here. Here's the most displacement, right? Displacement of the soil when you do the excavation. It's a ground 5 minus 5 because it's move different direction, right? So it says 5 plus e is where is power 12, okay, and you have the x direction also. Okay, you can consider by this way. So you have the displacement. So now to compare the displacement with and without retaining wall. So in my desk we have the so we want to do the retaining wall. So we need to have some of the definition of the interface wizards because the soil and the retaining wall have some interaction. So as you can see in the PPT here, this is interface wizard in Midas GTX NX. So they calculate based on the two functions. They find out the normal stiffness modulus and this is the bonding behavior. So bonding and bonding behaviors between the normal direction follow the pile length, but with the shear stiffness modulus KT. So this is the elastic modulus they will find based on this equation, as you can see, based on the equation. And then they have this is the represents for the slip behaviors. So follow the interface element normal direction to the interface element, and this is the strain reduction factors because the interaction between the pile and then the soil in settlements is different. So they must have some of the factors that shows these differences. So in methods they suggest for different material with different soil type, so different value in the range, as you can see in here. And the virtual thickness, they create like the virtual phase to between that two elements, and then the virtual thickness is suggested from 0.01 to 0.1, and in Midas they suggest that if the stiffness is high, use the smaller values. Okay, that is okay. So now in this study we will do the first we not considers in the virtual thickness and set at default is 0.1 meter, and then the reduction factors we will input at 0.67 as similar as the manual. Okay, so now we will go to now. So you have the simulation with a retaining wall as we did before, and now we create a new file and then later you compare. So you will self as and you create the file with retaining walls. Now we do the retaining walls, right? So now we will extract the element in here. So to create the element set for the retaining wall, now you can go to the match element extract and choose the add type. We want to choose the S because you open the geometry here and make sure that you are in method color. This is a match, and then if don't have it cannot extract your match, and then choose in here and choose the long pile, and then you just select the properties. Now when you extract the properties the retaining wall, our retaining wall, and choose the name for the method and apply. So now you can see in here the method 50 nodes and 48 element has been created for the method. Now so to see it a bit clearly, so you can turn on the properties of it. So you see it's 1D properties and D1 beam, so you open. So you can see here now this is the retaining wall geometry. Now you can see very clearly, right? This is a retaining wall in here, so you can turn off the geometry. Okay. Now we have the retaining wall. So to create the interface between the retaining wall and the soil, you go to the same place at the extract element match, element, and interface. So now we have the retaining wall properties of the truss and beam. So you choose truss and beam and select this element. Select this element from the truss and beam. Choose the merge node. These two nodes at the end to make the stability for the simulation. And then you choose the wizard. So they will use the last function that we discussed to calculate without manual input from us. So you have this, you save it, and you have the grid link, and a line interface will be automatically created and calculated and created in the property function. So you click apply. So now you can see that two line interface and grid mesh has been created. And now you can check by the properties. So you can see, because we have 4 solid layers, so the interface is divided into 4 interface properties, and one is the grid link. Okay, so and now we can go to the simulation to check back what is the difference in the displacement after we do the excavation. Now we go to the analysis, and in the stage set we can delete it. So now we can go to the stage set. So you create a new construction stage set and excavation with retaining wall, and then you add by simulation the stress and choose this and define construction state. First is we define the initial stress in the soil, and then you choose all the methods except for the line interface and retaining wall, because this we activate. You do the activate and select all the method, and then except for this two, line interface and retaining wall, and add into the activated data. So you can see the data now is the soil is activated, including the grid link match, and then you create the richest link match, and then it's changed into the line interface. That's how the GTX NX works, to change from the first grid link to the line interface. So below of this, you also need to define the boundary condition and then the gravity load. Okay, and then you clear the displacement, because you don't want to have any displacement consideration in here. And then you do the retaining wall. Now you still initial, and then you save first, and then you add new, and now in the construction you can change into the retaining wall installation by adding the retaining wall line interface and the excavate the activated the grid link match, and then you save for the second. And then now you excavation soil layer 1. This is a retaining wall, and then you save it and then click new, and then you excavate the first soil. You deactivate it. So now you can see in the model is the activate for you save it and new excavation 2. So you deactivate the data for excavation 2, layer 2, and new, and excavation 3, and then deactivate the data. Now as you can see, same as the previous. Now 3 excavation is performed, and including with the retaining wall, and you can save it and close. Now the construction state is defined, and now you go to the analysis case. You add a new analysis case with the title is excavation with retaining wall. Okay, and now you choose the construction state, and now it's our defined before applied, and yeah, it's appear here. You can run it for solving So after solving, we can compare the two files. So now I will open file, excavate width and without. So now I change the recent simulation of the width. So you can just select in here for the seeing. Okay, and now I will go to the result and the excavation layer thread, and also same way we want to see the XY direction displacement. Okay, and then now we can compare by the results of the displacement with the excavation also. Okay, and now we can compare by using tool vertical tile, and yeah, you can see now the results is short. That is the with with the retaining walls. This is the failure. The large displacement in the failures this is this error, and this is the large displacement in y direction is in here. Okay. This is the uh, simulation for the retaining wall and the comparison of the width and with the retaining wall. Thank you so much for your listening.